Hey everyone, welcome back to another video, and in this video we are going to talk about using the ultrasonic sensor, which is a sensor that's used by many self-driving cars. So this, in my opinion, is one of those inputs, or sensors rather, that can kind of open up the doors to what you could possibly do with an Arduino, because this is kind of where we start to get a little bit of diversity between all of the different components that we've studied so far. Okay, so let's take a look at first how it works, and then afterwards we're going to wire and experiment with it. So the first thing I want to talk about is, well, what is it, right? So the ultrasonic sensor is a sensor that can measure distance and basically give you the ability to measure how far away something is without any ruler. That's basically the idea. And, it looks like a pair of eyes. So you might be wondering, well, okay, I don't have a ruler, so like how is this working? I mean, it's not like it's going to like extend a ruler out of it, right? And so the main idea, right, is sound waves. So this trigger pin, right, is going to tell one of the eyes of the ultrasonic sensor to send a sound signal towards an object. Let's say the object is a pineapple, right? It's going to send a signal towards an object. And again, this is activated by the digital output pin that's labeled trig, okay? Then the input echo pin, right? So there's an input pin, trig was an output pin, right? The input echo pin waits for that sonic signal to bounce off of the object, right? So look, we send out a sound signal, then we receive a sound signal when it bounces off of this object, right? Which in this case is a pineapple. And so based on how long it takes for that signal to bounce back, we can use this to calculate distance. So that's the main idea here. So wiring the ultrasonic sensor, there's 4 pins. VCC is 5-volt input, so it's going to use the 5-volt pin on the Arduino. Trig is digital output, and that's used to send out a sonic signal. The input is PWM, and I'll leave you, as a thought exercise, I'll leave you thinking as to why it's PWM. I'll give you a hint. We're measuring distance, and distance is something that can change. And for ground, well, that's just what we're used to seeing. It just goes into the ground pin of the Arduino. Okay, so you might be wondering, like, okay, from this, right, I know that the sensor computes, like, how long it takes, and, it figures, we have to somehow figure out how long and, like, what the distance is. So, like, how does that math work? Well, the thing you need to know is that distance is equal to speed divided by time, and then speed times time is equal to distance, okay? And so this equation is going to be pretty useful in terms of calculating distance. All right, so let's go ahead and get started. So the first thing we're going to do is exit out of this circuit and make a new one. All right, call this 4.3 circuit. Okay, so wiring is actually not bad. Wiring is actually pretty straightforward. Remember, it's just those 4 pins, right? So let's grab the Arduino. Let's get an ultrasonic sensor. We're going to be using this one. Oh, sorry, not this one. This one. Not the one by Parallax. We're not going to be using this one. We're going to be using the HCSR04, right? The Parallax one's a little bit different. Okay, so the first thing is 5 volts. That's fairly straightforward. We know where that is. Okay, let's change this to red and let's straighten our wires. Okay, and then let's do ground because, we're also used to that. Okay, now let's do the other pins. So let's just do this one blue. Oh, no, I don't want to change the existing one. I want to change my new wire that I wired up blue. We're going to connect tray. Let's use pin 10, all right? That happened to be a PWM pin, but don't worry about it. You can still use digital write with PWM pins. Okay, and then the other wire, let's use purple. And that's going to need to be a PWM pin, and, well, 11 just so happens to be next to 10, so we'll just use 11. Okay, so that's wiring. The tricky part with ultrasonic sensors has to deal with code. So let's get started by changing this to text. Delete the pre-generated code. Okay, so the first thing that I want to kind of show you, actually, rather than, sort of teach you about ultrasonic sensors first, is defining variables, right? So defining variables. So if you remember, right, when we worked with that built-in LED, instead of writing number 13, we could write the word built-in LED, right? So that's something that's called a variable. Now, there are multiple ways to define variables and how to like give them a value and stuff in C++. Let's use the sort of macro way. So the way it works is you write the word hashtag define, and then you give the variable a name. In this case, let's call it trig pin. And then you hit space, and then you give it a value. So in this case, the trig pin is 10. And there's no semicolon that follows it. So that's the idea, right? So define, not define, we're going to do echo pin, that's pin 11. So that's the way you can define variables. The other way is declaring variables. So declare variables. Now, this is very straightforward and very familiar to the way you've maybe done it in another language like Java if you worked with that. But the idea is you specify the variable type, name, variable type, and name. You don't give it a value. We're not going to give it a value yet. We're going to do that in loop. So we're going to have a float, which is duration. Now, floats allow for decimal values. An integer, right, int, is not a decimal value, okay? That's just the whole number. So not float. Okay, cool. So this one is variable type name. This one is hashtag define name value. Okay, so that's how you go about making variables that you can later reference in code. Remember, this needs to be done at the very top, all right? So even before setup is initialized. So that's something else to keep in mind. Okay, so the first thing that we're going to do is set up trig and echo pins. Now it's going to be pin mode. Now instead of typing the pin number, right, we already defined a variable that holds the pin number, so it's just going to be trig pin and then output, right? And then we said that the echo pin, right, that's the one that receives the sound signal, is an input. Okay, and then we're going to begin the serial monitor because I want to print out the distance of the serial monitor. So serial.begin 9600. Okay, cool. So I might be wondering, like, well, where do I go from here? Oh, let me finish typing that. Okay, so the first thing that we're going to want to do, right, is set the trigger pin to output low for 2 milliseconds. So what we're going to do is digital write, trig pin low, and then we're just going to have a delay, where we're going to preserve this, or we're going to do delay microseconds. This is a built-in method in Arduino of 2 microseconds, okay? Now, the reason why we're doing here is you want to make sure the pin starts off with the low state, right? You don't want to randomly start with the high state because then your distance is going to be wrong. Because think about it, right? If I randomly started with the high state, then I'm basically saying that the second everything begins, I don't want to start fresh. Instead, I'm just going to start with whatever was before, right? Because think about loop. A loop keeps repeating, right? So if I don't cancel out my signal from before, I'm just going to use that old signal and it might get a little funky, right? So the idea here is you want to make sure the pin starts out low. So make sure, and this is another way you can comment. It starts and ends with a star and a / star and a star / That's another way you can comment. It's really up to you. I'll use the double line for now since that's what we've worked with. But basically you want to make sure the trig pin starts out low. This ensures we don't send out a random pulse. Okay, that's the general idea behind that. Next, you're going to set the trigger pin to high, which sends off a sonic signal, right? And we want to do that high signal for a certain amount of time, or let's say 10 milliseconds. And then we're going to turn it off, all right? So we're going to, so here's, right? So step 1, turn on trig pin for 10 microseconds. Step 2, turn off the trig pin. All right, so we're gonna send out that sonic signal. All right, so this is basically sending out the sonic signal. So it's gonna be digital write. I can't spell today, can't I? Okay, so digital write trig pin high. Then we're gonna delay microseconds, and then finally digital write. It's going to be trig pin low and turn it off. Okay, so that's that idea, all right? So, when the sound waves hit the ultrasonic sensor's receiver, the echo pin is set to high for a certain period of time. So we need that time right? We need to measure the time that's read by that echo pin, right? So instead of using analog read, which you might have thought is the counterpart to like digital read, for example, we're actually going to use a method called pulse in, all right? So pulse in takes in two arguments, which is the pin that you're focusing on and then the state that you want to focus on. So whenever the echo pin receives a signal, it leaves a high state on internally. And so we want to focus on how long that high state is for. So what pulse input does is it waits for whichever state you've specified. So it's going to either wait for high or low, and then it starts a timer for when that signal is reached, right? So remember, we need to figure out how long it takes for that sonic signal to sound back, right? So determine how long it takes for the sound signal to bounce back to the ultrasonic sensor. The signal bounces back when the echo pin, or rather when the I guess we could say when the echo pin reports a high signal has been read. So remember, high just means on, right? So whenever something is on, even at whatever, like, doesn't matter what the level is, right? As long as it's on, which means that we can read something, which means that something has bounced back, we want to start a timer, all right? So we're going to have duration, right? Duration, right? I should have specified here what these variables do instead of just writing them out. Let me move this comment to the top. And so this is the time taken for the signal to bounce back. And then this distance is distance read by ultrasonic sensor. Okay, so the duration is equal to pulse in, and it's going to be the echo pin, and we're going to look for a high signal. Okay? Now, the next part, right? We know the fact that speed is equal to distance over time. Remember that physics equation, right? So remember, speed is equal to distance divided by time, okay? So this means, if we do some algebra, that distance is equal to speed times time. We know time, which is duration. So what about speed? Well, that's going to be the speed of sound, right? We're using sound waves, right? And that's the main idea, okay? So the speed is the speed of sound because we're using sound waves. So as for units, the Arduinos work with centimeters per microsecond. So speed of sound value is going to be 0.0343. Okay, now one more thing, right, is we need to divide by 2. Because sound wave goes out from the sensor and then back in, right? So this pulse input, the high signal has been read. What that means is a high signal. What I really mean by that is that a high signal has been sent within the ultrasonic sensor, all right? So when is that high signal being sent? Well, that's happening here. We're doing it here, right? And so that's why we need to divide by 2, all right? Because whenever that high signal is sent out, we're actually going to be starting this pulse input function. Then we calculate the duration, but that's going to stop, right? Pulse input will stop whenever we read low. When do we read low? Well, we read low once everything's been read, and then this turns off, all right? So the idea here is that things are going to go out and then back in, right? So a state high or low we want to focus on. We only want to focus on when it's high, which means that it's sent out, and this high signal occurs whenever we bounce back, all right? So we divide by 2 because the signal goes out and then comes back in, right? So it basically travels twice the distance it should between the ultrasonic sensor and the object, right? So your distance is going to be your duration times the speed, right? Which is 0.0343. And then we're going to divide the value by 2. And that's it. And finally, we're going to print out the distance. And then we're just going to delay because I don't want to flood the serial monitor and I want some kind of a buffer, all right? So one thing you could do is within the print statements, you can actually add a bunch of extra things. So if I wanted to add like the word distance just to make the printout clearer, I can do something like that, where I add the string. A string is just a piece of text, right? You specify that with quotes. So you have the distance and then plus the variable distance, which is what we're setting right here. Okay, so let's go ahead and try this out. I'm going to start simulation. Oh, looks like the code has errors. Oh, never mind. I guess you can't do that. I must be wrong. Okay, don't do that. Let's go ahead and start. Okay, so notice that I can click on the sensor and I get this visual. Now, Tinkercad will tell me what the distance is supposed to be, and I can compare my code. Now, obviously, there's going to be some inaccuracies because, well, we're kind of dealing with, a little bit of simulated circumstances here. So let's see how good we can get. So I have 225.4. I get 225.54. That's reasonably close. We're off by 0.1 centimeters. I have 35.8. I get 35.77. Notice how accurate I am, right? Isn't that cool? Right? So right now I'm at 174.5. Let's see how far we can get. We can go up to 120 inches, almost 10 feet out from this tiny little sensor without any ruler. And we're pretty accurate. We're off by literally less than a centimeter. So not bad, right? So again, ultrasonic sensors, do they lack a little bit of precision? Yes. But you exchange that precision for this really small sensor that works quite well. So especially for working with intervals, like let's say you want to see if an object's like 5 centimeters or 40 centimeters away. Well, you could totally do that, right? If I set this to like 40, let's see how close we can get, 39, 40.8, right? I mean, we're pretty much there. We have it spot on, all right? So again, farther out you go, the more inaccuracy you'll see. The closer are you in, obviously you'll get better results. So, and this is just purely because the wave has to travel longer. So the longer you let the wave travel, the more inaccurate it's going to be. But you'll notice that the inaccuracy isn't actually all that bad. Like you're off by about a centimeter. Okay, so that wraps up ultrasonic sensors. The main thing to keep in mind is this whole physics idea and how this wave is sent out. The code is pretty straightforward boilerplate code, and what I mean by that is if you ever wanted to read distance from an ultrasonic sensor, just copy and paste this code. Like there's no need to memorize or manipulate what each part does. This code is literally designed to print out distance from an ultrasonic sensor. But remember, this course is all about implementation. So it's not just about reading distance, but rather what should we do with the distance. And we're going to talk about that in the next video. So thank you so much for watching, and I hope to see you in the next video.